Did you ever wonder how character AI works within Tycoon games? Well, in this devlog we're going to go behind the scenes of Mars Attacks and show how the characters work, and also how the cleanest solution isn't always the best. Before we get started, I should clarify that we're not talking about large language models or generative AI that all the tech bros are super hyped about right now. We don't use any of that stuff in Mars Attacks. When I'm talking about character AI, I mean the logic behind the characters within the game. So if a guest gets on a ride, why did they get on that ride? Or why did they get on a bench or take a drink? It's really about how the characters behave and what drives them to do the things that they do inside the game. I'm not personally an AI expert, but I have programmed the AI within Mars Attacks twice. So let me talk a little bit about the first attempt and then why I had to change to what's available in the game today. Every character in Mars Attacks has what's called a finite state machine, which essentially means they're just in one of several states at any given point in time, and they can only ever be in one state. The character has a set personality, which is distinct from every other character, and each personality has a list of needs that the character has to satisfy. Google tells me this is called motivational AI. So this is a rough visualization of my first attempt at structuring the logic, and essentially every character has a brain. Game code lets you implement behavior every frame, but because there's quite a lot of intense processing required for AI, I implemented a tick, so it only really happens every half second or second. Every tick, the character checks its state and checks that there's nothing blocking whatever it is that it's trying to do. If there aren't any blocks, the character will stay in that state and keep doing what they're doing, and the animations and model will react appropriately. If the state needs to change, then a check goes to the personality of the character, which tells it what the priority thing it is that it wants to do next. Once the character knows what it wants to do, a message is sent to a task finder module, which then works out how to do that thing. Assuming there's a way for the character to do it, the state updates and the character starts doing that behavior. So as an example of this system, let's say a guest is eating some food and they feel full. So their state needs to change, it goes to the personality, and maybe they need to use the toilet. So a message gets sent to the task finder tries to find a nearby toilet, and if it can find one, the state gets changed to walking as the character heads towards the toilet. To be totally honest, I was pretty happy with that solution. It was clean and efficient, and it was relatively easy to understand what stage the character was in and what they were thinking. There might be some AI programmers screaming at the screen right now, so if that's you and you have a better way of structuring this, then please let me know in the comments. I'd love to hear your input. So I was happily playing the game, expanding out the number of guests, and then quickly realized that as the numbers started increasing, this model perhaps wasn't the best for what we wanted to do within the game. First of all, characters were managing their own ticks, and even though for most of the frames they weren't doing anything, they had to check every frame to tell them not to do anything. That's not a big issue for small numbers of guests, but if you have into the thousands, then those small checks really add up. Another challenge with this model is that it couldn't use multi-threaded code. So there's a feature in Unity where you can take advantage of all cores within a computer's CPU, and this model just wasn't suitable for leveraging that. Another thing I hadn't really considered is the behavior of groups when every character is looking for something to do. So for example, if you had a load of guests in the park that needed a toilet, and then you built a toilet, then all of those guests would get the new information and start heading towards the toilet straight away. With every character individually controlling their own needs, it was really difficult to stop this flocking behavior whenever the player did something new. Another example of me maybe not thinking that far ahead is characters didn't understand why they were going to a destination, just that they needed to get there. So every time we implemented a different type of character, for example a janitor might go to a trash bin to empty it, whereas a guest goes to drop litter, each would require different states reflecting why they were going to a particular destination. Which meant we had a load of similar states that the character could be in, because the character's intention and their action were linked in a single data point. The solution that I came up with, which might be super obvious to people that do this a lot, is to separate the character's logic on how they behave from the data. The characters themselves no longer have brains that do the thinking, and all of the logic is controlled centrally in a global manager. So a single tick in the world checks every character and whether or not their state needs changing. If the character needs something new to do, the state checks the personality, which is now split up into individual needs. The top priority need sends a message to a global task manager, which then finds stuff for all of the characters to do at once. Instead of changing the character's state directly, the task finder now sends a task, which is essentially the intention of what the character wants to do, to the character's state. The state then updates the character's model and animation, so for example they could be walking, but the task is stored separately so the character knows when it reaches its destination what it is that it's trying to do. So there's three big advantages of this system. Firstly, checking all of the characters at once is far more performant than every character checking individually. Secondly, separating the needs from the personality means we can strip back the personality for special characters, for example a janitor, and then add in, let's say, a cleaning or a repairing need just for that character, which will handle all of the logic that needs to go to the task manager. And finally, having a task that is separate to the character's state means their character's current action is separate from its intention. So a character, for example, knows it's walking, but also knows when it gets to a destination whether it needs to empty a bin or fill it. As with anything, this is really just a progression of the AI system, and I'm sure there'll be lots more changes coming as the game develops further down the line. One challenge for future me is working on the multi-threading system to enable so many more guests to be active in the park at once. We're implementing lots of different types of characters now, and also a character memory system, so they know which rides and amenities they've visited and which they might want to go to as they explore the park further. We also really want to integrate more of the character and personality of the Martians. So for example, programming a shenanigans need where they actively look for entertainment through mischief and violence. If there are any suggestions or features that you'd like to see, then please let us know, because we're very open to ideas. We also run a competition with every devlog, so if you are a subscriber to the channel and drop a comment down below, you'll be automatically entered to win a Steam key when the game releases next year. The winner from the previous devlog is now listed down below, so if this is you, then get in touch and get your free key. Thanks very much for watching, and if you'd like to see how the game's key art was created, check out this video. See you in the next one.